Good day to you all. Evan Snowman here for Umuhloko, Making a Difference. Again, we're working through some Euclidean geometry examples, which I found from old exam papers. So again, let's read through the brief. In the diagram, we've got a triangle ABG with D and E on midpoints. Again, this being key wording, I'm going to choose to briefly mark it on the diagram that D is a midpoint and E is a midpoint. What I'm looking for here is to see if there is any line that joins D to E, because we know that a line that joins two midpoints is significant in terms of our geometry from grade 11. Okay, we do have that, by the way, DE. AG is reduced to C and H respectively. F is a point such that FG is parallel to CH. And again, I said to you repeatedly, we know that in grade 8, it meant that things are going to be alternate, corresponding, and co-interior. We now know in grade 12 that it means that the sides are going to be in proportion. Okay, so 8.2.1, what reason is DE parallel to BH? Again, in an exam or test situation, please take note of the mark allocation. The fact that this would be only worth 1 mark means it must be something very, very straightforward. But in this case, it is because of the midpoint theorem, as we were discussing in the brief. If we've got two midpoints, the line joining the two midpoints must be parallel to the third side of the triangle. So we can proceed to answer the question. We know that 8.2.1, that it is because DE is parallel to BH because of the midpoint theorem. D and E were given as midpoints. Okay, so we now know 8.2.2. We now know that as a result that this line is parallel to this line, and it should be in the ratio of 1:2 if we need it. Okay, we're now further given that the side FC in proportion to BF, so FC over here at the bottom, in proportion to BF, is in the proportion of 1:4. Okay, what does this mean for us? Well, it means that because these lines here are parallel, we know the proportion on the far side of this diagram. And so we know that therefore GH is in proportion to BG in proportion of 1:4 because of the lines being parallel. Because of what we just discussed from the midpoint theorem, we know that if this is the length 4, that this is 4, that DE will be half the length of BG. So we can now use that idea to solve this problem, having done some thinking and writing on the page, some preliminary writing on the page. So we know that because we've got FC to BF equaling 1:4, that this is also equal to HG to BG 1:4, because the sides are in proportion to one another, because the sides were parallel. So because we've got that FG is parallel to CH, given. So we now know that, we know that HG is given to us. Again, over here we can see we are talking about HG over here. And we've got given HG over here. And we've got DE. Well, we know that DE is half of BG. So we now know that, therefore, HG to DE will be in proportion 1:2, because BG is 2 DEs by the midpoint theorem. So what we now know is that, therefore, HG to DE is correct. So therefore, 2 HGs is equal to 1 DE. We've cross multiplied. And now we're going to plug in those values. We know that HG or GH is x plus 1 and DE is 3x minus 1. And so what we're going to get here is that 2x plus 2 equals 3x minus 1. Sorry for writing a little skew there. And as a result, when we bring things across, we get 3 equals x, and we are done with solving our problem. Okay, so this was quite an interesting question because we had to transfer from triangles that were lying in different orientations. One was situated vertically with some oblique lines that were parallel. Another one was lying on its back with the lines that were vertical, which looked vertical, that were parallel. The trick here was to keep track of all the information as we moved around the diagram. Okay, I'm now going to move on to my next example. And here we have a parallelogram with a line extended and another line that is cutting through this thing at a slant, but it is not a diagonal. Okay. Again, what makes this diagram different from the previous diagram is that the information is in the text, but is not drawn on the diagram. Again, I know that some exam centers allow you to write on the diagram. We write in exam booklets. Please make sure that you convey your information onto the diagram to aid your understanding of the material. Okay, so firstly, we're told that we've got a parallelogram. So we have it marked here that the sides are parallel. But please don't forget all the other implications of a parallelogram, such as sides being equal, and opposite places of angles being equal. We're told that AB at the bottom here is 14. We're told that AD to DE is in the ratio of 4:3. And we are told that EB intersects in F. We're also told that this entire length here, which I'm going to choose to mark here with a red highlighter, we are told that the entire length here is 21. So I'm going to mark that over there as being 21, albeit that I'm marked right here slightly out of the way. Okay, calculate with reasons the length of FB. Calculate then with reasons show that the two triangles are similar, and then finally calculate the length of FC, which is this little piece that is sitting outside the slant. It's going to be quite interesting to try and get to that one. Okay, so the first part is to realize that if we have this proportion 3:4, we need to look for a pair of parallel lines, which we have marked over there as being FC, but it means that DF is equally parallel to AB, which means we now know that the proportion of EF to FB is also in the ratio of 3:4 because of the parallel lines. So 9.1, we know that ED to DA, which is 3/4, is also equal to EF to FB because DF is parallel to AB, and it's the proportion theorem. As a result, we've spoken about this before, that if you have part to part, then we also have part to whole. So if EF to FB is 3:4, then we know that the entire length would have a proportion or proportional value of 7. 7 parts because of the 3 parts from EF and the 4 parts from FB. So as a result, we know that we're talking about FB here. So therefore, FB over EB would equal, 4/7. We know that FEB is 21. So therefore, FB is 4/7 of 21. And therefore, it equals, 7 goes in there 3 times, so it's going to equal 12 units, or we've got units. So 12 units. I'm going to choose to write that in here because we have been working with length later on. Please be careful, because already in my diagram, I'm seeming to confuse my lengths with my proportions. So what I'm going to choose to do here to try to separate that idea is I'm going to put my thing in here for units to show that actually is a length, whereas the ones without the markings of units actually are proportion concepts. So we know that FB is 12, which means that EF is 9 units, and this would be 12 units. Prove with reasons that these two triangles are similar. I don't think that's just, we're getting some experience now. We're using EDF, this top triangle outside the rectangle, outside the parallelogram, and EAB, the entire shape. So that's the entire shape. Well, again, there's a trick here to it, which I'm sure you've encountered before, and that is to remember that to take note of the fact that E is common. So 9.2 should be quite quick. In triangle, I'll put it in now, EDF and triangle EAB. 1 E is common. 2 EDF will equal A corresponding angles on parallel lines, and therefore it follows that triangle EDF is similar to triangle EAB, angle, angle, angle. I'm now going to try and move on to proving 9.3. 9.3 asks me to calculate with reasons the length of FC. Well, again, we've had a clue to it just now when we saw in question 9.1, when we were discussing the idea that the proportion 3 and the ratio 3:4 part to part, leading to the idea of proportion part to whole. This proportion doesn't only exist for the two sides on the outside of the triangle, it also exists for the baselines of this triangle. So we know, as a result, that the proportion between DF and AB is also equal to what's happening in this big triangle. So if we looked at DF over AB, DF is the second pair, and AB is the second pair over here in our triangles that we proved similar in question 9.2. And if we now looked at what we have on the right-hand side, which is, well, let's look at the left-hand side then. On the left-hand side, we will have ED, and we'll have EA, which means that we know that this is in the proportion 3:7. Again, the one part is 3, but the entire length was 7. So we now know that, therefore, these two things are in proportion 3:7. We also know that AB is 14. So DF over 14 equals 3/7. We can cross multiply and cancel, and we'll get that DF is 6 units. However, they weren't asking me for DF, they were asking me for FC. But what I need to realize here is that FC is the remainder or the other piece of DC, and we know that DC equals 14 units because it's the opposite side of a parallelogram. And as a result, FC will be 8 units. Okay, so there were some tricks to this one, mainly involving part to part and part to whole. I hope you followed through. Again, I would really encourage you, if you are allowed to write on the question paper, or to answer in the question paper in an answer booklet, to please draw on the diagram and at least keep track of your thinking where you can. Okay, going on to our final example for today. What looks like a much more complicated example, and what I need to do is read through it. Again, we've got a circle center, which has a whole lot of implications for us. What does strike me in this initial one is that we do not seem to have a diameter, but we do have a line going down to a tangent, and we do have various lines that are parallel. We are given a whole bunch of, we are told that these lines are parallel over here. We are told that C1 equals Y and O2 equals X. Yep, I can see that. There's the 1. There is C1 equaling Y, and there is, let's mark it in yellow, O2 equaling X. can see those. And we are told, importantly, that FH to HC, FH to HC, so this line to this line is in the proportion 2:3. Okay, so let's proceed and see what we can do with solving this problem. Calculate with reasons the size of J, or J1, in terms of X and Y. Okay, so let's have a look what we can do here. We know that we have parallel lines, so we should be able to get quite quickly that, where's my pen gone to? Okay, cool, come back. See, we'll just undo that. We know that O2 is going to be corresponding to this angle here at G, so that's going to be size X. We know that we have a tangent, so don't forget that every time we've got a tangent, we should be thinking about one of the three tangent theorems. Although right now we can almost immediately exclude the third of the three tangent theorems because we do not have a second tangent. So we've got tan chord in play here. So we know that if this angle here is y, there's my tangent, there's my chord. So that angle is equal to any angle that is subtended fully by that chord, and that angle would be angle at A. So we know that angle A equals y from tan chord. And we now need to get to J1. Okay. Again, thinking it through, we know that if we've got angle A being the size y, we also have the angle O coming off the same chord we marked here as BC over here at the bottom. So we know that this one will be twice as big, so it'll be 2y. And that allows us to now go and find J. J is in quite an unusual position, being here in the middle of the triangle, but not at the center of the triangle. And so if I looked at this triangle here, again, I'm going to mark it in orange. If I was to look at this triangle here that contains J1, I can see that actually I now have sufficient information to solve the problem. Okay, I can get from O1 to O4, and then I've got two angles inside that orange triangle, and I can then move on to the third angle of the triangle, like three angles of the triangle equals 180. So the trick now is to write it down, and again, as I've been encouraging you to do, what we do is we do it once for ourselves, we get our thinking straight, and then we do it once for the examiner, and we follow through. So we said O2 equaled X equaled G, corresponding angles on parallel lines. So it's E, not a Y, not an I. We said that if we've got C1 equaling Y, then C1 equals Y equals A by tan chord. And again, depending on your province, you need to put in information of what is the tangent and which is the chord. Therefore, we've said that O2 equaled 2y, sorry, not O2, O1, I apologize for that. That O1 equaled 2y, angle at center equals twice the angle at the circumference. And we've said that O1 equaling 2y meant that O4 equaled 2y, vertically opposite. And as a result, J1 would equal 180 degrees minus 2y minus x, three angles of a triangle equal 180 degrees. Okay, we are now tasked to find the proportion of GO over GC, GO over GC. And again, we have discovered, we're getting some experience in this chapter, in this concept now. So if we are looking at GO over GC, it's probably linked to parallel lines. So the parallel lines we're looking for are over here. Okay, and the nice thing is that if you backtrack it, this one goes back to G, this one goes back to O, So we can see that then we can use that proportion over here. So we have that G over GC, apologies, I'm going to quickly fix my handwriting, is equal to GO is equal to FH to GC is the entire length, so it will be FC. And again, part to part links to part to whole, so therefore we have 2 is to 5. And the reason here is because of the lines being parallel, so we have GF being parallel to OH and using the proportion theorem. And so we've completed our example and we've done with today's lesson. I hope you followed it nicely. All the best.